Hey folks, welcome back to Learn2Python, a video series designed around example-based learning and teaching for Python. This is the intro to the exercise video number uno that accompanies the first lecture video. If you haven't watched the lecture video yet, please stop the video and go find the Learn2Python lecture video number 1 and go watch that. Otherwise, you may be lost. Also, to clarify, some people commented directly to me that they were confused about where to find the Python files I referenced in lesson 1. You can find them at learntwodo.github.com/learn2python. I will have that URL in the description of the YouTube video, and I'll include it as an annotation here. Notice this is a web browser, this is a website, all pretty straightforward stuff. On the website, it's very important. We have lessons, exercises, and lesson downloads. Lesson downloads is where you want to find the Python files. If you open that up, you can actually see that it opens up this nice web page, and it shows you exactly what code you're downloading. The files you're downloading greet.py, you're downloading greetwithweather.py, and in each file, this is a code. You can download that, you can open it up, and you can use greet.py and greetwithweather.py. Pretty straightforward. Just wanted to make sure that everyone had this down because it's very important. Later lessons, the Python files will be much longer, and it'll be a pain for you just to copy it from the screen. So I want you to go to this site and actually download the raw files so you can use them and you can learn a little bit easier. Without further ado, let's move on to the exercises. The first exercise is going to be easy, and that's generally how these exercises are going to run. It's going to be from easy to medium to hard, but it's a very important exercise nevertheless. Let me redo the exercise first, and let me explain it, and then you can go ahead and try it. Without using the Python interpreter or the editor, aka without using your computer, write down the output of each of these statements below. What basically I want you to do is develop a very important skill I think all programmers should have, and that's the ability to read code without using a computer to run it. There's going to be a lot of cases in the real world, or just even by yourself, when you're looking at someone else's code and you want to try to figure out what it does. Oftentimes, you may not have the ability to run it on the computer, or the code might be broken, like it doesn't work, they wrote it incorrectly, so that you can't run it on the computer. In that case, you actually have to manually read the code and figure out where the code is going wrong, or perhaps what the code actually does. So it's a really important skill to develop and learn, and we'll hopefully be working on that throughout these lessons. So what I want you to do is look at these statements, these 3 print statements, print hello world, print hello comma world, print hello comma world, and write it down on a piece of paper, write the output down. What do you think the computer is going to output to you if you type in print hello world between quotation marks? I don't know, that's why I'm asking you. So grab a piece of paper, pause the video, grab a pen, and write down the output of 1, 2, and 3. Alright, welcome back for your first ever Python exercise. I hope you had some fun with it. I hope it wasn't too hard. And I'm here to help you along and explain the answers. So let's get right down, crack into it, or whatever they say. The first question was, what does print hello world output? Well, this should be fairly familiar. This is actually the first print statement that you actually ever saw. And as far as I can remember, because the words hello world exclamation mark are between 2 quotation marks, it's what we call a string literal. AKA, the print statement will literally print the string, or literally print the words hello world exclamation mark. Let's see what happens. Hit enter. Boom, hello world. Amazing. All right, let's move on. Print hello, comma, world, exclamation mark, parentheses, quotation mark. What do you think this is going to print? Well, it actually isn't very different from the first line, right? There's a comma there, but it's between the 2 quotation marks. So I think it's just going to print hello, comma, world, because it's a string literal. Should make sense? Make sense? Hit enter. Let's see what happens. Cool. It just prints hello, comma, world, exclamation mark. Neat. Now let's try the little bit tricky one. Hello, comma, world, exclamation mark, quotation mark, parentheses. What do you think is going to happen here? Well, I know that the word hello is a string literal, and I know that the word world, exclamation mark, is a string literal. But what does a comma mean? Well, doesn't a comma just mean we're just going to print both of these string literals on the same line? I mean, remember when we tried to print the numbers 3 plus 5, I believe? We did 3 plus 5 equals 2, and then we closed that with quotation marks, equals, comma, and then we did 3 plus 5 regular, and it all displayed on the same line. I think that's what's going to happen here. I think what we're going to see is just hello world, one line, no comma. Let's see what happens. Wow, cool, neat. So you see why that happens, right? If I type in print 1 plus 2 equals 2, comma, 1 plus 2, oops, 1 plus 2. It's the same thing that's happening in this line right here, except instead of having just a no quotation marks on the second thing, we just have quotation marks. And remember what happens here, we just do 1 plus 2 equals to 3. Same thing. The computer is literally printing out 1 plus 2 equals 2, and then it's evaluating 1 plus 2. In our case, the computer is literally printing out hello, and then literally printing out world. And the comma just separates it with a space. Good enough. Let's move on to exercise dose. All right, on to exercise 2. This exercise has the exact same instructions initially. I want you to, without using a computer, take your pen and pencil out, take your piece of paper, and continue on trying to write the output of 4, 5, 6, 7. You may notice that number 7 is a challenge, kind of difficult problem. It's going to be incorporating something you haven't really seen before. It's going to have this addition mark between the print statement, between the things you want to print. I don't really know what happens. I'm sure you don't really know what happens, but take a wild guess. Don't use your computer right now, at least. Just guess. Try to imagine what the computer might do with this. Pause the video. Take your pen and paper out. Try to write these down. And as always, after the break, I will explain everything. Welcome back to our favorite friend, the Python interpreter. This time we're going to be tackling question 2. It was definitely a little bit harder than question 1. And I think the 7th statement, the 7th print statement, or the last print statement, probably gave you guys a little bit of trouble. But that's fine. Let's see what happens. So the first statement that we wanted to print for question 2 was print 2 plus 4? No, just print 4. Yeah, print 4. That's a pretty straightforward, simple one. Remember, Python is a programming language, and programming languages talk to computers, and computers know numbers. We don't have to surround numbers in quotes because the computer already knows what to do with numbers. So it should just print the number 4. Yep, cool. Let's try printing 4 plus 2. Well, like I said before, computers are intelligent. They know what to do with numbers. You type in 4 plus 2, it will add the numbers together, and that's 4 plus 2, that's, is that 6? I think that's 6. Well, let's double check with the computer. Oh, that's fantastic. We get number 6, and it gets printed out. Cool. Now things get a little bit more tricky. 4, comma 2. What do we have here? Well, we know the computer knows what to do with numbers, and we know what the computer knows what to do with string literals. So what is a computer trying to print in this case? the computer is actually trying to print string literals out, right? Because we've surrounded the numbers with quotation marks. So the computer sees it as a string literal, as something it literally needs to print out, or it needs to literally print, or it needs to print literally, whichever combination works for you. Remember what the comma does. It splits up all the items and puts them on the same line and separates it with a space. So we hit enter, we should get 4 space 2. Oh, so cool. Okay, so the last one is a little bit complicated. It's something that I haven't taught you guys. It's showcasing kind of a neat side of Python that you guys haven't seen yet. But let's see if you guys guessed it right, or maybe you haven't guessed it right. Doesn't matter. I know I didn't guess it right the first time I saw this. If you ask the computer to print 2 string literals and add them together, what happens is the computer actually is intelligent, or Python is intelligent enough to mesh the 2 string literals together end to end. So when we hit enter, we should see 42. Let's try to see if it works. Oh, that's awesome. That's kind of neat. For instance, I can ask the computer to print school plus bus. Oops, I can't spell. And that gets us school bus. Isn't that cool? So there's some really interesting things you can be doing with this, and we're definitely going to be covering kind of string manipulation later, but just keep this in your head for now. If you have a plus sign between 2 string literals, or between any number of string literals, you basically attach them end to end, with no space in between. All right. Pull on your hats, put on your galoshes or whatever, and get ready to trudge on to question number 3. Now that you have your galoshes and your hat on, I hope you're ready for a change in scenery, because that's what question 3 is. Question 3 asks, how would you change the output of this line from hello Nathan exclamation mark to hello Nathan exclamation mark? Nathan, what are you asking me to do? Well, this question is a little bit more subtle. I hope you I hope you recognize this code, the print hello name exclamation mark. I hope you recognize that code from our very own greet.py function. That's the first function that we ever wrote together. So special. So you can see, when it prints out, the output actually says hello, Nathan space exclamation mark. I'm not really sure why that keeps on happening, but it does keep on happening. And because I'm a grammar Nazi, that's really annoying. In fact, that's so annoying, I'm getting annoyed. So what I want you to do is change around how the innards of the print statement, the parameters rather, and see if you can create an output that says hello, Nathan exclamation mark with no space. Remember something very important. This is part of a function, and the function asks us a name and it outputs that name that we give it. So you can't just hard code in and say quotation mark hello, Nathan exclamation mark and say, oh, I finished, because that's just kind of cheating. I want you to somehow mess around with the function and maybe realize that there's a little trick that I want you to do that lets you remove that space between the name and the exclamation mark. Go for it. Try it. Open up your idle and play around with that. Pause the video right now. Come back whenever you're ready. All right. Did you have fun with question 3? Finally becoming a programmer, writing code, being all mysterious? Anyways, question 3 asked if we could remove that space between the exclamation mark and our name. And let me demonstrate this space here. Greet Nathan. Oops. Enter. Hello, Nathan. Oh my gosh, it's a space there. The grammar Nazi in me is screaming out in pain. How do we fix that? Well, you know that little trick I showed you, exercise 2, I believe, 5 minutes ago? That trick with the plus sign, how you could use a plus sign to squish things together. School plus bus equals to school bus. Now, you can actually apply that same trick here. Even though name isn't really a string literal, it is really a string literal because we're inputting it as a string literal. Does that make sense? Because we're typing in because our name parameter or our name variable is the value of Nathan between quotation marks, then we can basically replace the name here with Nathan in quotation marks. That's basically what we're doing, right? So name plus exclamation mark should remove the space, I think. Let's run the module and see what happens. Let's type in greet Nathan. Enter. Oh, wow, that's awesome. Hello, Nathan. No space. The grammar Nazi in me is happy. Let's move on to question 4. This is the last question of the first exercise set. Don't worry if these seemed a little bit easy. I just wanted to kind of make this to get your feet wet, rather. The next lecture and the next exercise set will be much harder. No worries. This is the last question and the 4th question of the exercise set. Don't worry if they all seemed a little bit easy. I just wanted to boost your self-confidence because I know you have none. Welcome to the 4th and last question of the exercise set. Don't worry if the problem seemed a little bit easy or even a little bit medium hard. They will get harder as we go on, but for the first kind of set of exercises, I wanted to make sure that everything went as smoothly as possible. Because learning and understanding the base of how I do things is very important. So, on to the question. How would you algorithmically make a PB&J sandwich? You notice I have PB, peanut butter, in brownish, and J, my favorite jam is blueberry jam, so it's kind of like a purplish blue. Anyways, how would you make a peanut butter and jelly sandwich algorithmically? Well, Nathan, what do you mean? I mean, in computers, like you saw with the function or the print statement or whatever, things get executed line by line, and not only do they get executed line by line, you have to tell the computer what to do every single line, right? You have to say to the computer, hey computer, I want you to define a function. I want you to define the function's name as greet. I want greet to have a parameter called name. I want you to print out hello, and I want hello to be in a string literal, etc., etc., etc. With computers, you have to pretend like they're very little kids. You have to tell them exactly everything and exactly everything in the correct order before they can do it properly. Well, we're going to practice that type of thinking. Something as easy as a PB&J sandwich, something I bet most of you guys, or all of you guys rather, could make in about 5 minutes, given peanut butter and jelly and some bread. How would you algorithmically make a peanut butter and jelly sandwich? How would you tell a robot or your computer to create a sandwich for you? Think about that. Write it down on a piece of paper. I want you to label your steps. Step number 1, get off your chair. Step number 2, grab some bread, etc., etc. And then start with nothing, end with a peanut butter and jelly sandwich. Come back and I will tell you how I make my peanut butter and jelly sandwiches algorithmically. Alright, so I decided it'd be more fun if I had the computer tell you what I like to do to my PB&J sandwich and how algorithmically I would make one. It will start listing out the steps, and it'll have 4 seconds between each step, which will give me time, hopefully, to explain very fast. So step number 1, get out of my comfy chair. Step number 2, grab 2 slices of Wonder TM bread. 3, open fridge door, of course, because we want to take the blueberry jam and our peanut butter out of the fridge, because blueberry jam's the best. Number 5, close the fridge door, because we don't want to waste energy. Number 6, take the butter knife out of our drawer, so we can spread this stuff. 7, we want to open the jam jar and peanut butter jar so we can put our butter knife in. Number 8, we want to spread the peanut butter on one slice of bread with the butter knife. Number 9, spread the blueberry jam on the other side of bread with the other side of the butter knife. Stop. Hammer time. Oh, yes, secret ingredient. Number 11, grab some brown sugar and cinnamon from our cabinet and mix it together. Number 12, liberally apply brown mix to the peanut butter side. Number 13, clean up the ingredients because we don't want to leave a mess. Number 14, smush the 2 slices of bread together. Number 15, nom 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 nom. That is the best type of peanut butter sandwich anyone can make, in my opinion. And that is an algorithmic, rather, albeit very wordy, way to make a good peanut butter sandwich. As you can see, the computer tells me exactly what to do and where to find things, right? Thank you for watching this exercise video. I hope you had some fun. Keep your eyes peeled for the second lecture, which is actually coming out tomorrow night because I'm ahead of schedule. Thank you very much. Remember to go to learntwodo.github.com. I totally said that wrong, but you can find that in the description below to get all the files that I used in the lecture and in the study guide. Thanks.